Good day, G10 learners. We are about to start our week 3 for Mathematics 10. We will discuss another sequence, and it is called geometric sequence. For our objectives, after going through this module, we are expected to illustrate a geometric sequence, differentiate a geometric sequence from an arithmetic sequence, and appreciate the value of sequence in our daily lives. What is new? In your module, page 11, we have the learning task 1. So in learning task 1, we will determine if the pattern illustrates is a geometric sequence or not. As of now, you don't have the idea on how to identify if the given sequence is a geometric sequence or not. Given this example, I will discuss how it can be identified. So for number 1, we have 5, 10, 20, 14, 80. And from the first term, which is 5, it is multiplied by 2. So the next term is 10. Then 10 multiplied by 2 is 20. Then 20 times 2 is 40. Then 40 times 2 is 80. So the pattern of the given sequence is that every term is multiplied by 2 to get the next term. And that is a geometric sequence. Okay? So let's proceed with number 2. We have 3, 6, 9, 12, and 15. So from the previous discussion, we can see that this is not a geometric sequence but an arithmetic sequence because the given sequence has a common difference of 3. For number 3, we have 1/8, 1/4, 1/2, 1, and 2. This is a geometric sequence. Every term is being multiplied again by 2 to get the next term. 1/8 times 2 is 1/4. 1/4 times 2 is 1/2. 1/2 times 2 is 1. For 4, we have 1, 3, 9, 27, and 81. This is also a geometric sequence. From the first term, which is 1, it is being multiplied by 3. So 1 times 3 equals 3. Then 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. Number 5, 10, 9, 8, 7, 6. So this is an arithmetic sequence. It is not a geometric sequence. So the common difference here is -1. Given the sequences in learning task 1, you can now identify if the given sequence is a geometric sequence. Let us define. A geometric sequence, or also known as the geometric progression, is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio, which is commonly represented by R. Let's try illustrative example 1. So we have the number pattern 1, 2, 4, 8, and 16. This is a geometric sequence. 2 is multiplied to any term to get the next term. So we can say that 2 is the common ratio. The common ratio, it can be an integer or fraction, which is pwedeng negative or positive. And it can be found by dividing any term by the term that precedes it. This is represented by small letter r. And let's continue. So now that we have determined that the given sequence is a geometric sequence, let us try to find the next two terms in that given sequence, given that the common ratio is 2. Let us try to have the sixth term. Sixth term is 16 times 2, which is 32. And the seventh term is 32 times 2 equals 64. Now, what could be the 8th term and the 9th term? So that will be 64 times 2 is 128 and the 9 term is 128 times 2, which is 256. So that is how you can identify the next term in a geometric sequence. For illustrative example 2, so in the sequence 3, 8, 13, 18, and 23, we can say that there is no common ratio among the terms because it has common difference of 5. With the criteria, let us differentiate arithmetic sequence and geometric sequence. So, on how to generate the terms, in arithmetic sequence, we add a fixed number to any term. Then, in geometric sequence, we multiply a fixed number. Then, the fixed number in arithmetic sequence is called common difference, while in geometric sequence, it is called common ratio. And to find the fixed number, in arithmetic sequence, we can determine the common difference by subtracting the two consecutive terms, while in geometric sequence, we divide the two consecutive terms to find the common ratio. So that is the end of our lesson for this week. So this lesson is divided for 2 weeks. So the continuation will be on the week 4 discussion. Thank you for watching. Keep safe and God bless you all.